Thanks very much, Peter, and thanks to you and the other organizers for inviting me back. It's a real pleasure to be here. And now this is going to be something completely different from the other talks that you've had in this workshop, in this conference, although not different from some of the sort of discussion sessions like this morning's or yesterday afternoon's. There won't be a single equation in today's talk, I'm proud to say. What I want to talk about is I went too far. A sense that the casual observer may get, who's not sort of embedded in a context like BHI, working with physicists day in, day out, but somebody who just occasionally looks at Facebook and blog posts and The Atlantic or something like that, might get the sense that philosophy and physics are at a kind of a Cold War state at times. I'll give you a few tastes of some of the shots that have been fired here, just to because it's funny and it warms up the crowd. Philosophy is a field that unfortunately reminds me of that old Woody Allen joke, those that can't do teach, and those that can't teach gym. And the worst part of philosophy is the philosophy of science. The only people, as far as I can tell, that read work by philosophers of science are other philosophers of science. It has no impact on physics whatsoever. Ouch. The revered Stephen Hawking has at times taken shots at philosophy too. Here he said, most of us don't worry about these questions most of the time, but almost all of us must sometimes wonder, why are we here? Where do we come from? Traditionally, these are questions for philosophy, but philosophy is dead. Philosophers have not kept up with modern developments in science, particularly physics. Again, ouch. But it's not all one way. Sometimes philosophers try to hit back. And here's, this person is not a philosopher of physics or science. He's a legal philosopher. And in his blog, he comments that, of course, it was not always so with physicists, but the current generation, at least those who try to speak to the broader public, does seem remarkably inept in logical and rational thought, and unembarrassed to display it to the world. Which raises the question, why? My best guess is that the culture so celebrates physics that physicists have come to believe the PR about themselves. So that's another ouch. All of that took place, most of those quotes were from 2012 to 14, and things have calmed down in some ways, but there have been some heated discussions on Facebook and other social media type sites lately. Sometimes, I'm not going to discuss the content, much less the names. A lot of the blog posting happens under anonymous handles, and so I will defer to that anonymity and not talk about the people who are posting under their own names. But the point is, there's been one interesting fracas in a physics blog that's been going on for more than a year already, and has more than 1,100 posts in the comment section of this blog entry. And it centers around black holes and the information loss problem. And so it's very interesting. It's been, as I said, a year-long debate, and unfortunately there's been much more heat than light generated, which I think is a missed opportunity. So in a sense, after being a spectator to this ongoing fight for a year, I felt like I wanted to talk about why there can be friction between our communities in philosophy of physics and why we can do better. At the same time, an interesting trend that's happening is that there seem to be more and more philosophers invading the archive and publishing papers, people like Faraz and Eric, for example, and very often it's in something having to do with black holes, like black hole entropy and thermodynamics, the information loss problem, papers exploring ADS-CFT, duality in general. And this, it seems to me, I would like to say it's a very good trend. I mean, philosophers of science shouldn't just talk among ourselves. We should actually try to say something to scientists. But the question is, are these engagements being fruitful? And here there's a problem, which is sort of an eternal problem for doing philosophy of physics. It's a kind of I'll call it a Scylla and Charybdis for the philosopher of physics. You've got to sail a very narrow path between two sharp rocks, One is if you are not very interested in challenging what physicists are saying or the logic of their arguments and so forth, but you're interested in exploring the interpretation or making some distinctions and drawing some conceptual framework in which to discuss things, well, then it may just look like you're just repeating what the physicists have already said with a lot more words than equations. You're just being a physics cheerleader or something like that. On the other hand, if you're critical and raising conceptual problems that the physicists maybe don't seem to be talking about and you think they should, you're likely to be told that you're just wrong and what you're talking about is out-of-date physics anyway. We got over that 3 years ago and so on. So it can be very difficult to do interesting philosophy of physics when you're trying to present it to physicists. So too often when philosophers write papers about real issues in physics, they end up being dismissed. Sometimes with good reason. I'd like to think not always. And so what I'm going to talk about for a lot of my talk is the why. And clearly it has to do with the fact that we're distinct cultures and distinct disciplines. And there are some important differences that I'll try to describe a little bit later. Differences in the kind of assumptions or background beliefs that are standard in your field. Differences in what you might call epistemic standards. What constitutes a good argument? What constitutes proof? And values. What are we really aiming at? What in a piece of work? What matters to us more? There are also, I think, just differences of intuition. What strikes you as interesting, important, a sound argument, or something to be pursued? These are intuitions, and we all are educated and develop those intuitions in graduate school, and of course philosophers and physicists normally are not doing graduate school in the same context at all. Finally, there's huge differences between the sociology of the two disciplines, given their places in society these days. So all these differences can easily lead to friction, misunderstanding, and underappreciation of each side for the other. I'll say more about these in detail shortly. But I want to come back to the point that Peter made just before lunch. We have identical goals even today. So everybody knows that physics is an offshoot of natural philosophy, which was just part of philosophy and still is. I consider myself a natural philosopher. And the shared goal of natural philosophy and physics is still identical, which is to completely understand physical nature, nothing less than that. So, given this identity of purpose, I think improved interactions ought to be possible if we understand better our systematic differences and try to turn them into advantages. So that's where I'm going to be heading. But first, this occurred to me several weeks ago as something I'd like to mention, and then of course it was sort of the topic of yesterday's discussion that Ramesh led. We also face nowadays a kind of a similar problem in philosophy and in physics. Now these guys, this is René Descartes, the father of analytic geometry and also one of the most important philosophers of the 17th century. This is Immanuel Kant. And both of these guys worked on the hardest central problem in the theory of knowledge for philosophy, which is how can we know anything about the world outside our own minds? And this is Roger Penrose, if you didn't recognize him. So we've got a kind of a shared veils of perception issue in philosophy and in physics these days, although they're different problems. Here's the traditional philosophy problem. You really, in a sense, know what you're thinking and seeing. You're knowing the contents of your mind, and it seems to be telling you about a world outside of you, but how can you be 100% sure that everything that you think about the world that your perception teaches you is really actually true? So that's the skeptical doubt that Descartes tried to resolve. And Kant, in a different way, said, actually, you can't, but don't worry about it. And then when it comes to physics, of course, we've got with black holes, we've got the event horizon problem, which is the problem, how can we ever know, in the sense of really know completely for sure, what happens inside an event horizon? As we talked about yesterday, you can jump in and maybe satisfy your curiosity before you die, or maybe not. But from the outside, we'd like to really know. Now, I'm one of the philosophers who's kind of optimistic about these epistemic issues, and I think that we can give answers to these questions. And the answers are going to be similar in the two cases. Once we have a theory of how everything works, and I do mean sort of everything, light, human eyes and brains, and on the other side, a full empirically adequate quantum gravity theory, then we simply trust what our highly confirmed theory tells us. There's more to the story I'm going to have to skip over here, but that's the way I think about it. And we need, in the process of getting this confidence, though, we have to make assumptions. Powerful assumptions, but reasonable ones. When it came to deciding that we can trust our senses about the external world, you have to at least assume that there's no sort of all-powerful being trying to deceive you. And Descartes actually tried to give an argument for that, but his argument was bad, so we just have to assume that. In physics, one of the assumptions that you need to make if you ever want to have confidence about what's going on behind the event horizon, you have to have the confidence, make the assumption there is such a thing as a true, complete, fundamental theory of everything. I'm a philosopher of physics who does share this assumption. I think a lot of physicists share this assumption, but not everybody does. Yes?
Why do you need to know that? Why is it partial just enough? Just know the laws that in the interior.
So
Piece of it, right?
it might be enough, depending on what it gives you confidence about and what you can test. That's a good point. Yeah, it might be enough.
You believe that there's something else that doesn't matter for what you're thinking about right now.
But here what I had in mind actually, more than the ultimate theory of everything, was just believing that everything in nature is indeed governed by mathematical laws that we can discover. Okay, talking of assumptions then brings me back to the differences between our communities that I mentioned before. And I started with divergent assumptions that tend to be made. This is going to be, well, my whole talk is a bit broad brush and caricature, but these descriptions will be especially so. So I'll give on this column some things that philosophers tend to assume, and then contrast that with what physicists tend to assume. By no means am I saying that everybody fits these descriptions, and a lot of people would be falling on one side or another. But this is an important one that causes friction these days. So philosophers are educated by and large to assume and believe that there is such a thing as the measurement problem for quantum mechanics, and that it's serious, and therefore that standard quantum mechanics, as currently understood and taught in ordinary physics classes, really can't be fundamental. Philosophers, let me skip ahead. This was supposed to appear over here. By contrast, physicists would tend to believe that Einstein's criticisms of QM were regressive, wrong-headed, and that when we finally get to a fundamental theory, if we do, or at least to theories we're completely happy with that integrate gravity with quantum theory, it will again be a recognizable quantum theory. And in that sense, there's not this big problem that the philosophers often say there is. Philosophers believe in a kind of a realist physicalism, by which I mean, when I say physicalism, I mean that the philosopher will say that the point of physics is to describe what's out there intrinsically and not to talk about our own heads. I mean, indirectly, the theory about what's out there should have a lot of implications for what we should believe and what we can observe and everything, but the inside is not the point. So there have to be what John Bell dubbed beables and not just observables in the world. And physics is not fundamentally about information. That would be a widely shared assumption among philosophers. I think some physicists think that physics may well be at bottom about observables and information. Maybe not a majority, but that's an opinion you'll hear. And many philosophers think, I don't think this, but many philosophers think that physics is currently in a period of crisis for various reasons. And one of the reasons had to do with the lack of any new experiments that were really changing the standard model or giving us reason to throw out something important. It was a remarkably long period of time that you might think of or see physics as having been in a kind of a empirical dry spell.
Astronomy provided real.
And then astronomy did. Yes. So I think that is no longer something you can maintain.
You mean particle physics when you say physics?
Yeah. Okay, good. And finally, I think many physicists think, and maybe they're right, that 80% of things are already figured out, and we're still trying to get that last 20%, but that's fine. All right, standards and values. I'm running low on time, as Peter just reminded me. For the philosopher, clarity and intelligibility are taken to be paramount, whereas I think, in a sense, predictive success and is overriding in the physics community. For a philosopher, I think a lot would agree that a theory is not intelligible unless the claims it makes about the world in principle could be stated in words. Now that doesn't mean, when you have to write down some equations, and that doesn't mean you read out the symbols one by one. But it means that you can express in other words the essential content that's being captured by those mathematical formula. An attitude that may be common in physics, a theory can't be fully expressed without its mathematics, equations, and they are where the clarity lies, not in the accompanying text written in a natural language. Oops. Finally, philosophers would tend to think empirical success is necessary but not a sufficient condition for believing in a theory. Andreas yesterday talked about the underdetermination problem, which is one reason for that. And I think it's more common to take amazing predictive successes like we have from quantum field theories as an indicator of truth, if not actually constitutive of it, and thus as good grounds for believing in a theory. And finally, intuitions, well, these are not so important. I think I'll skip ahead. But the sociologies of the two communities are important. It still is the case, although less and less so as the years pass, that individual work, publishing a single authored paper, is the norm in philosophy. And of course, in physics, that's not at all true anymore. Philosophy works on a longer and slower time scale. Right? We trace ourselves back to Plato and Aristotle 2,500 years ago. And some of the issues they were talking about we're still worrying about. And physics is mere centuries old and makes much quicker progress by anybody's appreciation. The progress is sometimes hard to see in philosophy, and so one of the things that gets thrown in our faces is 2,500 years and you're still talking about the same questions with no progress. But there can be clear progress, and it's often considered to be cumulative in physics in a certain sense, which you don't see quite the same thing in philosophy. As academics, philosophers of physics, per se, are a slightly eccentric subspecies of philosophy, which is a besieged discipline these days. Maybe at Harvard it still has its old prestige, but philosophy departments are being closed down in many countries in the world, and the value is being questioned. And with the economic crisis, many people stopped sending their kids to study philosophy. And of course, physicists are the kings and queens of the scientific world. And finally, philosophy has this cult of the genius where a few of the most incredibly intelligent people get the lion's share of the attention and drive the way that the field develops. And oops, that's the same for physics. So with such huge differences between the communities, why bother trying to get along, let alone actually work together the way is happening here at BHI? Now I want to say one thing up front, which is that I think that physicists can do their work without talking to philosophers. It's not going to grind to a halt if the philosophers suddenly withdrew to another corner of the world. But for sure I can say that philosophy of physics profits from interaction with physicists. The more that we get, the better we do our job. And I'd like to be able to hope that at times the inverse is true, at least to some extent. So the idea that I want to plant with you is that two epistemic cultures with different values and assumptions and intuitions tackling an issue together may actually be better than one if both of those cultures are basically sound and good and open to thinking outside their paradigm and boxes. And I think that black hole physics is perhaps an ideal proving ground for this. which is one of the reasons I'm so happy that the BHI is doing what it's doing. Peter, I should be 60 seconds. Just to mention some examples where I think this kind of interaction can work. Assessing the significance of all the stuff that has been done in ADS-CFT. And I mean various things, but actually some of the things that came up in that year-long blog war that I mentioned before had to do with the question whether the quantum gravity theory that will end up being true of our world can be believed to be relevantly the same as ADS bulk theories. And can we transfer the conclusions that we get from our work in ADS-CFT directly to what we should believe about this world, and if so, with what assumptions, what premises, and so forth. And there are other examples having to do with black hole thermodynamics, which happened last year at this conference. We talked yesterday about whether we know that black holes exist, and these are the information loss paradox and the status of its premises. These are all things in which I hope that bringing philosophers together with physicists might be profitable, but time will tell. The keys are to understand the differences between our communities and appreciate them for what they are, and working side by side can help that a lot. We need to be willing to talk about the assumptions, methodology, and so forth in ways that we don't usually do within our own disciplinary work. And it always helps to check your feelings of superiority at the door. All right, thank you.
So one of the things that made me upset at the first BHI conference was to see some philosophers that have an inferiority complex relative to physicists. That's a sign, I think, that's not a good quality. Because one of the philosophers basically said that if physicists agree on something for a decade or more, we should regard it as the truth, or we should accept it as a valid assertion. And that's historically not true. I mean, communities, because of social reasons, social pressure, I mean, a large number of members of a community that creates an echo chamber may believe in something that is not tested empirically, and then it turns out to be irrelevant. And that happened a lot in the history of physics. So the role of philosophers is to say that. It's not proven yet. This is, although popular, although these physicists give awards to each other and great respect and get a lot of funding and so forth, it may not be the truth. And so I think by no means having a particular period of time over which physicists talk about the same thing means that they are doing the right thing.
Thanks.
Ramesh.
So, Carl, I was struck by this in one of your tables. Philosophers want words, physicists want equations. And I wanted to explore that in more detail, exactly what you meant. Because what I have heard as a physicist is you have to get it down in the mathematics, clear equations, solve the problem. But then, it is what I was told was, having done all of that, you have to understand your result well enough that you can explain it to your grandfather, okay? And without using those equations, exactly what it means. Is that the sense in which you were talking when you said philosophers want to get to the words, or is it something more than that?
No, that's exactly the sense.
Okay.
Yes. If your grandfather is a pretty intelligent person.
And not a physicist. Daniel?
So I do think that sometimes philosophers of physics can make useful contributions, contributions that are useful for us as well. And I think, for example, this book by Richard Dewey was a recent example of that, where I wouldn't say that anything he said is surprising to me, but it's convenient to have a place where it's discussed clearly. And so when people say silly things, you can say, no, just go read that that book and it'll explain it to you, you know. And there are a lot of sort of debates, especially like you said in the blogosphere, which I view as sort of more normative rather than scientific, about, you know, what people should be working on, or how long is too long for something to be having papers written about it, or how do we as a community decide, you know, which things are you know, are promising. And you know, these are the kind of things which I guess we talk about over lunch and, you know, have some intuitive sense about, but we don't really usually think hard about it. And you know, it's, at least for me, it's kind of useful to, you know, hear from people who sort of really think hard about that kind of question. Because, you know, for us it's a distraction. You know, I don't want to spend, you know, my time, you know, fighting with Peter Boyd, right? I mean, it's just, you know, it's a different skill set, and I feel like maybe for philosophers, they're closer to this, having the right skill set.
I agree, yeah.
You know, one older example of a good connection between philosophy and the sciences is certainly Immanuel Kant's early work on galaxies, which helped make that concept part of our current vocabulary. And another example that I hold great hope in is quantum mechanics, where the collaboration between philosophers and physicists in the more recent decades helped make quantum entanglement and the quantum technologies, quantum cryptography and all the associated things that have been part of that, into something that's now current and interesting, from quantum computing all the way down. And there was a period when talking about entanglement got the response shut up and calculate during the 1950s. And it's good that we hope to bypass the decades-long separation of the two realms of thought. Thank you, Carl.
Thank you.